Hi, kids. Okay, I am eventually going to lead to something called Pascal's principle, but this is also going to be a brief little piece of notes that's going to explain how a hydraulic lift works. So we'll talk about that as well. So let's say we have two columns of fluid, column A, and column A is pretty full of fluid. Okay. And then I have column B over here, and column B is not quite as full of fluid. Okay, and it really doesn't matter. Well, that doesn't look very good, but it really doesn't matter, guys, as far as the shape of this, because hopefully one of the things you just learned about was that the question I'm asking is which one, okay, at the bottom is going to have more pressure. Okay, and it really doesn't matter the shape of it. This one could be long and skinny. This one could be fat, because hopefully you guys got this. That pressure strictly depends on what pressure you have at the top plus the rho gy, so like the height of it. So this one, is going to have more pressure because it's steeper. You know, if you go to the bottom of a pool, well, you're going to experience more pressure because you're deeper down than at the top of the pool. Okay. But yeah, this one's going to have more pressure, this one would have less pressure. Okay, let's then pretend that I connect these two things, okay, with a pipe. Like, yeah. Okay, if I connect these two things with a pipe, what's going to happen, because there was a high pressure here and there was a low pressure here, well, guess what's going to happen? Fluid is going to flow like this. So that this level is going to drop, this level is going to raise, until they get to the same level. Okay, so like you're going to get to a point where it's going to look something like this. And again, well, big whip, you know, that makes total sense. Okay, but but that's why it happens. Okay, that whatever volume goes down here, that volume goes up. Okay, but there you have it. And it will equal out because it has to equal out. If it doesn't equal out, then this side would have more pressure than this side, and then it's gonna, the fluid's gonna flow one way or the other. Okay, so yeah, that's okay. That should make sense. So that means again, hopefully you guys got this because this is one of the most important things. If you were to pick any height level, so like right that. Okay, the pressure here and the pressure there has to be the same. Okay, because it's at the same height. Okay, and this is true for any enclosed fluid. Okay, so for any enclosed fluid at a given height, the pressure will be the same. Okay, very, very important. Okay, the equation that shows it was the equation we did before, which is essentially P2 equals P1 plus rho gy, where this is the same because this is the same. That's going to be the same. Okay, all right. So there's that. All right, now let's talk about like what they do with the hydraulic. Okay, so let's say that I had this situation going on, and then I'm going to push down on the top of this. Well, how do I push down on this? Well, I can't push on fluid, so I'm going to make like a plunger. So here's this plunger that I'm going to put on top. Okay, and I'm going to use that to push down like that. Okay. Well, if I push down here, hopefully everybody agrees that if this goes down, so that this is now going down, well, this, has to go up. Because that fluid has to go someplace. If you push the fluid down, well, that fluid has to go up. Well, even after this happens, so if I'm pushing down over here, even after this happens, this is still true. So if I was to pick any given height, okay, so like, let's say like this, well, the pressure here has to be equal to the pressure there. Okay, well, if you go like this, well, now it doesn't work because now you're not inside the fluid, okay? So obviously the pressure here would not be the same as the pressure there because there would be atmospheric pressure and here Wouldn't, but you get the idea, okay? So as long as you're inside the fluid, okay? Hopefully that makes sense to you, because that's important. Let's see, what else? Which really is leading us to, that's actually leading us to Pascal's principle, and that's what Pascal said. Pascal came up with this idea that, you know what? If I add more pressure over on one side of a fluid, well, every place in that fluid, the pressure is going to go up, okay? And how much is the pressure going to go up by every place? Well, whatever pressure I added here, okay? So Pascal's principle reads this, okay? You can, if you want to read that all, it says an external pressure applied to an enclosed fluid is transmitted unchanged to every point in the fluid. If you add more pressure, hang on, at one point, then the pressure every point goes up. Okay, and really that's what I want you guys to write for Pascal's principle, is that Pascal's principle is that if you add more pressure one point, the pressure every other place goes up. Okay, and then the next thing is going to be, well, how do they use this to, let's say, lift a car? You know, if I want to use this to lift up a car, well, here's what they do. They use this idea of Pascal's principle that if you add more pressure one place, the pressure every place has to go up. But remember, pressure is force divided by area. So if I make my area big, I can make my force small, or vice versa. Okay. So let's say I have, this is my situation. So I have a small little tube here, and then I have something big on this side. Okay. Because over here is where I'm going to put my car, okay, my car. Well, if I want to raise up the car, so like again, if I increase, okay, my pressure on this side, well, this side is going to go up. So if I push down over here, this side goes up, so that whatever pressure now I'm adding over here, okay. And the pressure on this side would be, and hopefully this makes sense, P2 equals P1, so atmospheric pressure, plus the pressure that I'm adding. Well, the pressure that I'm adding would be the force that I'm exerting divided by the area. Okay? Well, this side is going to go up. Okay? So that this side, if this side goes up, the amount that this side goes up, okay, is going to be equal to, the pressure on this side would be equal to my atmospheric pressure plus rho gy, okay, where this y would be how much it raised up, and then those two pressures would have to be the same. So like if I was to go like this, okay, well, at this point, my pressure is here, atmospheric pressure plus this. Well, at this point, okay, I would get atmospheric pressure plus the pressure from all this fluid up here. Well, they have to equal one another. So, in other words, I'm going to end up with the force divided by the area is going to be equal to rho gy that I get out, okay, which would be how much the stuff goes up. And if you wanted to even talk about, well, if I want to get more force out, then we could do it that way. All right? Bye, kids.